Most teams think they have AI governance. They don't. They have compliance checklists. They have human-in-the-loop approvals, access controls, and rigid deployment policies. And for a world constrained by the speed of human software development, those mechanisms worked. But software development is actively changing. Autonomous agents are now writing code. They are reviewing pull requests, modifying live infrastructure, and deploying changes. These agents execute complex operational sequences at a velocity that traditional manual review cycles simply cannot process. The uncomfortable truth is that most governance programs were engineered to govern people, not machines. That gap is exactly where the next generation of catastrophic engineering failures will emerge. For years, the technology sector has centered its attention on the models themselves. The conversations have revolved around model safety, bias, explainability, and regulatory compliance. Those remain important considerations, but AI-native software teams face a different challenge. The primary vulnerability surface has moved away from the core model. It now resides in the permissions, the runtime controls, and the deployment path surrounding it. The engineering challenge is no longer answering the question, can we trust the model? The challenge is architecting strict, reliable boundaries to dictate what an autonomous agent is actually allowed to do. This 10-part series was designed specifically to answer that exact platform engineering challenge. We begin by exploring why software companies require a governance mindset completely detached from traditional responsible AI frameworks. This diagram outlines the 5 layers of agent governance: identity, action, output, change, and outcome. This provides a framework for understanding where governance gaps actually exist. Beneath those layers lies the missing contract. Agent instruction files, explicit skills, and rigid system rules serve as the governance substrate. If you fail to establish an explicit digital identity and a rigid rule contract at this base layer, it becomes impossible to secure any of the actions an agent attempts downstream. Moving from foundation to live execution, we have to account for inevitability. Autonomous systems will make mistakes, and they will make them at machine speed. This introduces the necessity of blast radius management. Engineering automated agent kill switches and rapid rollback mechanisms matters significantly more than attempting to prevent errors entirely. To execute containment, static written governance documents must be discarded. They need to be transformed into policy as code, executable directives that are continuously tested and enforced by the pipeline itself. This commit tree illustrates the growing traceability crisis in modern software supply chains. Organizations must maintain the ability to definitively prove who or what autonomous system authored a specific line of code. During live execution, governance abandons manual human oversight. It relies entirely on automated containment and irrefutable digital attribution. Beyond individual executions, managing a fleet of agents across an entire enterprise demands a shift in operational realities. Updating an agent's capabilities is not equivalent to updating documentation. It is a live software deployment. It requires strict canaries, strict versioning controls, and rigorous change management practices. This dashboard shows a shift away from strictly financial tracking toward capability budgets. These operational controls explicitly cap an agent's permissions and access limits within the system, regardless of the financial cost of their tokens. The industry currently relies heavily on vanity metrics to justify AI investments. Instead, engineering teams need methods to measure actual sustainable productivity and real organizational improvement driven by these deployments. Scaling AI safely means managing agent operations and system budgets with the same rigor applied to cloud infrastructure. This matrix represents the AI-native governance maturity model. It serves as the master framework organizations use to assess their current standing and chart their operational progress toward mature automation. The objective of this 10-part series is not to restrict AI innovation or layer on bureaucratic red tape. We engineer brakes in high-performance vehicles not to drive slowly, but to drive extremely fast without crashing. Robust governance systems allow organizations to accelerate safely. A successful AI-native system must demonstrate 6 distinct traits. It must be explainable, traceable, observable, controllable, recoverable, and measurable. The future will not belong to the companies capable of deploying the most agents. It will belong to the companies that engineer the systems to govern them. Most teams think they have AI governance. They don't. This is the complete architectural blueprint for how to build those systems. If you are experimenting with AI agents inside your organization, share your experiences in the comments. Subscribe to follow this series as we examine each chapter in depth. Welcome to AI Native Governance.